Imagine it's the year 2035. You're walking through the outskirts of Stuttgart, Germany, what used to be the beating heart of European manufacturing. The wind whistles through broken windows of a massive factory complex. Inside, precision machinery sits cold and silent, covered in a decade of dust. This was once home to 3,000 engineers who built the world's most advanced automotive components. Their tolerances were measured in microns. Their quality standards were legendary. But today, the lights are off. The machinery is cold, and the only sound is the echo of your footsteps through empty halls. What you're about to see will challenge everything you believe about German engineering. According to the VDI Engineering Association, 3 million skilled workers will vanish by 2030. That's not just a projection. It's based on demographic data that's already locked in. And BASF, Germany's largest chemical company, just announced a $10 billion factory expansion. The catch? Not €1 is being invested in Germany. It's all going to China. But before we tour this ghost factory, imagine you're Hans's neighbor. Your pension fund is 40% invested in German manufacturing stocks. Your son just started engineering school last fall. Your retirement, scheduled for 2032, depends on this economy not collapsing. Quick note before we dive in. What I'm sharing is analysis and research, not professional financial advice. Your situation is unique. Always do your own research and consult professionals before making any major financial decisions. So this isn't an academic question. This is about your money, your family's future, your industry that might be facing the exact same pattern. Right now, a silent catastrophe is unfolding in Germany. And unlike what you've been told, this isn't about one company making bad decisions, or one policy mistake, or one technological disruption. This is about 6 lethal factors hitting at the exact same time. I'm talking about the Spaltmass fetish, how obsession with hardware perfection became a liability in the software era, energy suicide, the policy decision that tripled electricity costs overnight, the Grey Tsunami, 3 million retirements with 0 replacements, the fax machine fortress, bureaucracy so ossified that Tesla's Berlin factory took longer to permit than to build, China Shock 2.0, when your student becomes your superior, and the Kodak Moment, arrogance so deep that management genuinely believes they're immune to the same forces that killed Kodak, Nokia, and Blockbuster. Any one of these would be manageable. But all 6 at once? That's not a crisis. That's a structural break. And here's what nobody's telling you. The same pattern is playing out in your industry right now. The geography changes. The story doesn't. So in the next 20 minutes, I'm going to show you exactly how this happens. Give you the timeline for when it accelerates, the 5 warning signs to watch for, and the 3 things you can do this month to prepare. Because panic is not a strategy. Preparation is. Let's start with something that sounds ridiculous, but reveals everything. Spaltmass. It's a German word that means panel gap, the tiny space between a car door and the body. German engineers are obsessed with it. They'll spend weeks perfecting a 3mm gap, making sure it's uniform to within 0.1 mm across the entire vehicle. And look, I'm not mocking this. This obsession built Mercedes-Benz. It built BMW. It built a reputation for quality that dominated global manufacturing for 70 years. But here's the problem. While German engineers were perfecting the panel gap, they completely missed the shift to software. Let me give you a specific example. In 2020, Volkswagen launched the ID.3, their first major electric vehicle. This was supposed to be Germany's answer to Tesla. They had spent 3 years and billions of euros developing it. The hardware was flawless. The panel gaps were perfect. The build quality was exceptional. But they had to delay the launch by 6 months because the software didn't work. The infotainment system crashed. The over-the-air updates failed. Basic features that Tesla had been doing for years, like remote climate control, simply didn't function. Here's the cultural clash. German engineering culture says you don't ship a product until it's perfect. That works brilliantly for hardware. You can't fix a bad panel gap with an over-the-air update. But software doesn't work that way. Tesla ships beta software knowing it's imperfect, then iterates rapidly based on real-world data. They push updates weekly. They fix bugs in days, not years. The German approach, wait until it's perfect, means by the time you ship, your software is already obsolete. Now multiply this across the entire industry. German automakers have 40,000 engineers working on electric vehicles. Guess how many are software engineers? Less than 15%. The rest are mechanical engineers doing what they've always done, perfecting hardware. Meanwhile, Tesla is hiring software engineers at a 4-to-1 ratio to mechanical engineers. The skill set that made Germany dominant in the 20th century, precision mechanical engineering, has become a strategic liability in an industry where the actual product is increasingly defined by software, not hardware. And here's the kicker. This isn't about intelligence or work ethic. German engineers are brilliant. The problem is institutional. The entire education system, the company hierarchies, the promotion criteria, everything optimizes for mechanical perfection, not rapid software iteration. So you have this paradox. The better you are at the old thing, the worse you are at adapting to the new thing. Your strength becomes your weakness. And that's just factor number one. Now let's talk about how Germany shot itself in the foot with energy policy. In 2011, after the Fukushima nuclear disaster in Japan, Germany made a decision: shut down all nuclear power plants by 2022. At the time, nuclear provided 25% of Germany's electricity. The plan was to replace it with renewable energy, wind, and solar. Noble goal, terrible execution. Here's what actually happened. Germany went from having the cheapest industrial electricity in Europe to having the most expensive. We're talking about a tripling of costs in a decade. Today, German manufacturers pay about 3 times what American manufacturers pay for the same kilowatt-hour of electricity. Now, if you're making software, energy costs don't matter much. But if you're BASF producing chemicals, or if you're a steel mill, or if you're smelting aluminum, energy is 30 to 40% of your total costs. So when your energy costs triple, one of two things happens. Either you pass those costs to customers and lose market share, or you eat the costs and go bankrupt. BASF chose option 3, leave. That $10 billion investment I mentioned, it's going to China specifically because electricity there costs 1/3 what it costs in Germany. Same company, same process, same product. But the input cost difference is so enormous that it's cheaper to ship chemicals halfway around the world than to produce them domestically. And this gets worse. Germany bet everything on natural gas, from Russia to fill the gap left by nuclear. At peak, 55% of Germany's natural gas came from Russia. Then Russia invaded Ukraine. Overnight, Germany lost access to cheap Russian gas. They had to import liquefied natural gas by ship at 5 times the price. This caused a cascading crisis. First, the chemical industry, then metals, then automotive suppliers. Anyone dependent on energy-intensive production started shutting down. Here's the math. If your energy costs go from 10% of revenue to 30% of revenue, and you're operating on 8% margins, you're now losing money on every unit you produce. You can't fix that with efficiency improvements. The only solution is to move production to somewhere with lower energy costs. And that's exactly what's happening. It's not just BASF. Bosch moved battery production to Asia. Siemens is shifting turbine manufacturing. The pattern is consistent. Keep the engineering R&D in Germany, but move the actual manufacturing elsewhere. Which sounds fine until you realize, if you separate engineering from manufacturing for long enough, you lose the tacit knowledge that comes from having engineers on the factory floor. Eventually, your engineering advantage erodes too. So Germany created a doom loop: high energy costs, manufacturing exodus, loss of industrial base, fewer high-paying jobs, smaller tax base, less money to invest in fixing the energy system. And unlike the software problem, which is cultural and could theoretically be fixed with education reform, the energy problem is geopolitical. Germany can't just flip a switch and get cheap energy back. They shut down the nuclear plants. They can't restart them. And renewable energy, while growing, won't replace baseload industrial power for another decade. So this isn't a temporary setback. This is a long-term structural disadvantage that could take decades to reverse, baked into the cost structure. That's factor number 2. Now let me introduce you to the man whose retirement will bankrupt the system. The one whose neighbor you are in this story. Meet Hans. Hans is 58 years old. He's a senior mechanical engineer at a mid-sized automotive supplier in Baden-Württemberg. He's been there for 30 years. He started as an apprentice at 18, worked his way up through every level of the shop floor, and now he's one of maybe 200 people in the world who truly understands how to manufacture a specific type of high-precision transmission component. His knowledge isn't written down in manuals. It's in his head. It's the accumulated wisdom of 30 years of solving problems that textbooks don't cover. When a machine makes a weird noise, Hans knows what it means. When a part fails quality control, he knows why. Hans is retiring in 2030. He's looking forward to it. He's earned it. Here's the problem. There's no one to replace him. His company used to run an apprenticeship program. They'd take 15 to 20 young people every year, train them for 3 years, and gradually build the next generation. But they shut down the program in 2015 because it was too expensive, and we can just hire experienced engineers when we need them. Except now, there are no experienced engineers to hire, because everyone else made the same decision. Germany's demographics are brutal. The birth rate has been below replacement level since 1970. The country is literally running out of young people. By 2030, 3 million skilled workers like Hans will retire. The number of young people entering the workforce to replace them, about 1.8 million. That's not a labor shortage. That's a demographic collapse. Now let's talk about the pension math, because this is where it gets truly ugly. Germany's pension system is pay as you go. That means current workers pay for current retirees. It works as long as you have more workers than retirees. In 1970, there were 4 workers for every retiree. Today, it's 2 workers per retiree. By 2030, it'll be 1.5 workers per retiree. The government has 3 options. 1. Cut retirement benefits, political suicide. 2. Raise taxes on workers, economic suicide, they'll leave. 3. Print money and accept inflation, everyone's suicide. None of these are good options. But here's the real kicker. Hans isn't an exception, he's the median. Every company has hundreds of Hans engineers retiring in the next 5 to 7 years, taking their institutional knowledge with them. This is what economists call a knowledge cliff. All at once, decades of accumulated expertise just disappears. And unlike the energy problem, which is about costs, or the software problem, which is about skills, the demographic problem has no quick fix. You can't train a 25-year-old engineer to have 30 years of experience. Time doesn't work that way. That's factor 3. Let's talk about bureaucracy. In 2019, Tesla announced they'd build a gigafactory near Berlin. This was huge news, an American company choosing Germany for a major manufacturing facility. The factory was supposed to take 18 months to build and get operational. Want to guess how long the permitting process took? 2 years. Let me repeat that. It took longer to get permission to build the factory than it would have taken to actually build it. And this wasn't because of some complex environmental concern or legitimate safety issue. This was pure bureaucratic ossification. Here's one example. German building permits require submission by fax or physical mail. In 2020, not email, not digital forms, fax. When Tesla tried to submit documents electronically, they were rejected. They had to print out thousands of pages and physically mail them to multiple government offices. Each office had to review the documents, stamp them, and mail them back. If there was a single error, a missing signature, a wrong date format, the entire package was rejected and had to be resubmitted by fax. Meanwhile, Tesla built a similar gigafactory in Texas in 18 months, and in Shanghai, 10 months. Germany, 24 months just for permits. Texas, 18 months total. China, 10 months total. Now imagine you're a company deciding where to invest. Every month of delay costs money. Every regulatory hoop costs time. You don't choose Germany unless you absolutely have to. The German response to this is always, but we have high standards. We do things the right way. Okay. But does doing things the right way require fax machines? Does quality really demand a process that's literally slower than in developing countries? Here's the deeper problem. This bureaucracy isn't just annoying, it's self-reinforcing. Every regulation spawns more regulations. Every rule creates the need for more enforcement, which requires hiring more bureaucrats, who then create more rules to justify their existence. And because government workers have lifetime job security in Germany, there's no mechanism to fix this. You can't fire the people slowing everything down. You can't streamline the process without their permission. And they'll never give that permission, because it would make their jobs obsolete. So innovation moves somewhere else. If you're a startup with a breakthrough technology, you don't come to Germany. You go to places where you can actually build things. This is how industrial leadership dies. Not with a bang, but with a form that needs 3 signatures and has to be sent by fax. That's factor 4. Here's a story German executives don't like to talk about. For decades, the relationship between Germany and China was simple. Germany provided advanced manufacturing and engineering expertise. China provided cheap labor and a massive market. German companies would set up factories in China, train Chinese engineers on German methods, and everyone won. Except at some point, and most German executives missed the exact moment, the student became the teacher. Let's look at electric vehicles. In 2010, if you wanted a quality EV, you bought a Tesla, or you waited for a German automaker to make one. In 2024, if you want the best EV technology, you buy BYD, a Chinese company. BYD's latest models have better battery technology, longer range, faster charging, and more advanced autonomous features than anything Volkswagen or Mercedes makes. And they cost 30% less. How did this happen? Well, remember all those German engineers who went to China to train Chinese manufacturers? They trained them very well. Chinese engineers spent 15 years learning German precision manufacturing. Then they took that knowledge, combined it with Silicon Valley software culture, added massive government subsidies, and built something better. This is what economists call moving up the value chain. China isn't competing on cheap labor anymore. They're competing on technology, quality, and innovation. In many sectors, they're winning. And German executives are genuinely confused by this. They keep saying things like, "But we invented this technology. How can they be better than us?" The answer: because invention and execution are different skills. Germany is still good at invention, but China has gotten better at execution. Here's a specific example: battery technology. German companies invested billions in battery research. They have patents, they have PhDs, they have state-of-the-art labs. But Chinese companies like CATL and BYD are actually manufacturing batteries at scale, iterating rapidly, driving down costs through mass production. They're shipping millions of units, while German batteries are still in the development phase. By the time German batteries are ready for mass production, Chinese batteries will be another generation ahead and half the price. This is the China Shock 2.0. The first China Shock, in the 2000s, was about low-skilled manufacturing moving to China. This second shock is about high-tech, high-value manufacturing moving to China. And unlike the first shock, there's no easy comeback. You can't just retrain workers when the entire ecosystem, the supply chains, the specialized suppliers, the manufacturing expertise, has moved to another continent. That's factor 5. Now, if you're watching this from America or Australia thinking this is a European problem, you're missing the point. The same pattern, specialization without adaptation, demographic collapse, bureaucratic ossification, is playing out in Detroit, in Toronto, in Melbourne, in every industrial hub that refuses to evolve. The geography changes. The story doesn't. Which brings us to the final factor, the one that makes all the others unfixable. Let me tell you about arrogance. In 1975, Kodak invented the digital camera. An engineer, named Steve Sasson, built the first prototype in the company's lab. It worked. Management saw it. And they killed the project. Why? Because digital cameras would cannibalize their film business. and Kodak was the undisputed king of film. Why would they destroy their own golden goose? Fast forward to 2012. Kodak declared bankruptcy. Turns out, if you don't cannibalize yourself, someone else will do it for you. Germany is having its Kodak moment right now. German executives know about the software problem. They know about the energy crisis. They know about the demographics. They've read the reports. They've attended the conferences. But there's a persistent belief, it's almost religious, that German engineering excellence will somehow overcome these challenges. That quality will triumph. That the German brand is too strong to fail. Let me read you an actual quote from a German auto executive in 2023. Chinese EVs might be cheaper, but customers who want real quality will always choose German engineering. That's the exact same thing Kodak said about Japanese cameras in the 1980s. That's what Nokia said about smartphones. That's what Blockbuster said about streaming. Here's what actually happens. Customers don't care about your legacy. They care about the product in front of them today. If a Chinese EV is better and cheaper, they buy the Chinese EV. Brand loyalty dies at the point where the quality gap becomes obvious. The deeper problem is institutional. German companies have hierarchies that reward experience over adaptation. The people in charge are in their 60s. They built their careers in an era where German engineering was unquestionably dominant. They fundamentally cannot accept that the rules have changed. This is what management consultants call living in a kind of Narnia, a fantasy world where the old rules still apply, disconnected from the reality everyone else can see. And the longer you stay in Narnia, the harder reality hits when you finally come out. Germany has less than 10 years before the demographic cliff hits, less than 10 years before the energy disadvantage becomes permanent, less than 10 years before the software gap becomes insurmountable. The window to fix this is closing, and most German executives think they still have plenty of time. They don't. That's factor 6. So let's put this all together. 6 factors, all hitting at once. A cultural obsession with hardware in a software world. An energy policy that became a competitive suicide note. A demographic time bomb with the fuse already lit. A bureaucracy designed to prevent change. A student that became a master. And a leadership class living in fantasy. This isn't a cyclical downturn. This isn't a temporary setback that government stimulus can fix. This is a structural break. The Germany that dominated global manufacturing for 70 years is already gone. What comes next is unclear. But it won't be a return to the status quo. Now let me give you the timeline. Here are the 3 dates you need to remember. 2027. Peak demographic cliff. This is when the largest cohort of skilled workers hits retirement age simultaneously. Companies that haven't solved knowledge transfer by then will start failing quality audits. 2030. Pension math breaks. The worker-to-retiree ratio hits 1.5 to 1. Expect either benefit cuts, tax increases, or both. 2035. Critical threshold for automotive. By this date, Chinese EVs will have 15+ years of production iteration advantage. The gap becomes extremely difficult to close. Note, these are projections based on current trends. Economic systems are complex, policy changes, technological breakthroughs, or geopolitical shifts could accelerate or delay these timelines. Mark these dates. Now, I know this sounds overwhelming, and if you're feeling a mix of anxiety and paralysis right now, that's completely normal. When you see structural problems this deep, the instinct is to freeze, to hope someone else fixes it. But here's what I've learned. Awareness without action is just sophisticated anxiety. So let me give you something actionable. Here are 5 early warning signs that your industry is facing the same pattern. Sign 1. Your company's average employee age is over 50 and rising. Sign 2. Key knowledge holders are retiring faster than replacements are being trained. Sign 3. Your biggest cost advantage from 5 years ago has become a cost disadvantage. Sign 4. Regulatory compliance takes longer than actual product development. Sign 5. Leadership dismisses emerging competitors as not understanding quality. If 3 or more of these apply to your industry, you're watching Germany's movie in real time. You just don't know the ending yet. Now here's what you can actually do. 3 things. This month. Action 1. Audit your skill portfolio. What percentage of your value comes from skills that are becoming commoditized? If it's over 50%, start learning something adjacent. Action 2. Map your industry's hands problem. Who are the irreplaceable experts nearing retirement? What happens when they leave? Start capturing that knowledge now. Action 3. Stress test your assumptions. Find someone who fundamentally disagrees with your industry's conventional wisdom. Listen to them without defending. These aren't complete solutions, but they're starting points that don't require permission from anyone. Here's the final lesson. Germany's collapse isn't really about Germany. It's about what happens when any system optimizes so hard for one game that it can't adapt when the game changes. The same pattern destroyed Kodak. It destroyed Nokia. It's destroying traditional media right now. And the uncomfortable truth is, you're probably playing the same game somewhere in your life. We all are. The question isn't whether disruption is coming. It's whether you'll see it in time to adapt. If this video helped you see something you couldn't see before, subscribe and hit the notification bell. I'm building a channel around understanding structural shifts before they become obvious. And if you know someone working in an industry that's showing these warning signs, share this with them. Sometimes the most valuable thing you can do is help someone see what's actually happening. One final thing. Remember Hans, the 58-year-old engineer retiring in 2030? He's a composite, but he represents thousands of real engineers across Germany. His story is their story. And he's not worried about himself. He's got his pension, his savings, his garden. He's worried about his grandson, because the world his grandson is inheriting isn't the world Hans built his career in. And that, more than any statistic, is what this story is really about. Preparation, not panic.